Today we're going to do a few quick scale drawing word problems. We've done a lot with scale and scale factor and converting units and proportional items and direct variation. It's all about proportionality, and that's what we're going to stick with today. So um, very real world uses today. Let's get right into it. A map is drawn with a scale of 1 inch equaling 8 miles. Two towns 2 3/4 inches apart on the map are how many miles apart? Well, whenever I'm given a scale, usually the first thing I do is write down that scale in fraction form. 1 inch is equal to 8 miles on the map. So 1 inch equals 8 miles. 1 inch on the map is equal to 8 miles in real life. So and now what I'm going to do is take the other piece of information they give me. Two towns are 2 3/4 inches apart on the map. How many miles apart are they? So the question is, as we set up this proportion, where does that 2 3/4 go? It goes on the top, 2 3/4 inches on the map. We're trying to figure out how many miles that equals in real life. So there's our proportion. And there's our scale. It's equal to 2 3/4 inch over x miles. And then we'll use cross products here. Okay, 1 times x is equal to 8 times 2 3/4. Done a lot of this. Okay, so anytime we've got a proportion like this, their cross products will be equal. So 1 times x equals 8 times 2 3/4. 1 times x we know is x, and I'm going to multiply 8 by 2 3/4 by turning 2 3/4 into a improper fraction, and then doing some simplifying and then multiplying. So two towns that are 2 3/4 inches apart on the map are 22 miles apart in real life. So I don't think something like that's going to blow anybody's mind as long as you get the 2 3/4 placed in the right spot and your variable placed in the right spot. Now on part B, or example B, Mariah is making a scale drawing of her apartment. Her apartment measures 36 feet long and 30 feet wide. She wants the drawing to fit on an 8.5 by 11 inch piece of paper. Which of the following would be a good scale for Mariah to use? Why? Well, the first thing I would do is, you kind of got to check all of them to see which is going to work. For example, on this first one, the room is really 36 feet. So just using some mental math here, a 36-foot long room would have to be represented by 18 inches on the scale drawing. Now I've only got an 11-inch piece of paper, so it's just not going to fit. So if we do that again here on B, again 36 feet is going to have to be represented by 12 inches. And that's not going to work either. Again, I only have an 11-inch piece of paper. If you're wondering where I'm getting these, 2 times 18 is 36, so 1 times 18 is 18. 3 times 12 is 36, so 1 times 12 is 12. Okay, so let's do it again here on C. Okay, 4 times what is 36? 4 times 9 is 36, so we'll do 1 times 9 is 9. Okay, so we got a 36-foot room being represented by a 9-inch drawing, and that would fit on an 11-inch piece of paper, so that would work. It's also 30 feet wide, which is going to be, I don't know, about 7.5 inches, so that'll fit on here too. So that's going to be the one we'll use. And I'll answer the second follow-up question here, why? Because this is the largest scale that will fit on the paper. So it's the largest scale that'll fit on the paper. Yeah, sure, the 1 inch equaling 6 feet will fit, but it would be smaller. So, this one would only be 6 inches wide. But yep, that one will fit, so we'll use it. It's kind of trial and error to do that kind of problem. Edmund wants to convert the attic to living space. He has made a scale drawing that is 1 inch equals 16 feet of his plans. What are the dimensions of bedroom 1? Well, on his drawing here, he's got it labeled. I did some measuring for you. Just trust me. It's 1 inch and a half an inch high. So how big is that in real life? This is his drawing. So how big is it in real life? Well, the length, you'll take that 1 inch and multiply it by the scale factor, 16 foot for every inch. See how the inches cross off, and we get 1 times 16 is 16 feet. I mean, that one's pretty obvious. I mean, you can probably do that in your head, but I'm showing you here a method that works. 1 inch is 16 feet. This is 1 inch, so obviously it's 16 feet. The half an inch, it's a little bit more complicated when you use fractions of an inch, but you guys probably know it's 8 feet already, so that's good. Half an inch times 16 feet per inch. See the inches cross out again, and 1/2 of 16 is 8. Okay, so maybe we didn't need this setup to do maybe a simple problem like this, but you can see how this setup would help if maybe it was 7/8 of an inch. It's a little bit more confusing, and you can see why multiplying the measurement by the scale factor. Okay, now a proportion would work for this as well, but I think you guys will like this method. There's definitely lots of different ways to do these problems. But definitely use common sense to make sure your answer makes sense. So let's do that now. A 16 foot by 8 foot room. Yeah, that makes sense. It's kind of skinny. Usually you don't see many rooms under 10 feet, but 8 feet will work. Okay, that's all I've got for you today. We'll see you tomorrow.